Okay, hello everyone. So welcome to the SuperMap mini classroom volume 7. So this is Firdaus Aragandus, technical support engineer from SuperMap Software Co Ltd. Okay, for today we will have the 7th edition of the SuperMap. We'll discuss more on the 3D cadastral solution by SuperMap iDesktop. Okay, first of all, I would like to give you an introduction first about the SuperMap company in case one of you is not familiar enough with our company. Okay, so yeah, SuperMap was founded in Beijing in the 1997 by Dr. Edison Zhong. Okay, wait. And for approximately 23 years, we already have humans to solve spatial problems with GIS as the main foundation. And we have more than 4,000 employees that's spreading in all around the world, more than 1,000 partners coming from the more than 30 countries. And also we do also have 38 branch offices and subsidiaries that's spreading in all around the world. And yeah, so this is important information you need to know about SuperMap is related with our 5 main key technologies. So start with the first one is the big data GIS. We support to handle the whole process of big data, start from the streaming data, storage management, do spatial analysis on it, and also the visualization as well. And the second one is the AI GIS, or artificial intelligence and GIS integration. So here we have 3 main functions that provided by SuperMap: GeoAI, AI for GIS, and GIS for AI. And the third one is the 3D GIS. So SuperMap itself has developed its function leads to 3D modeling from 2009 by integrating some technology like data model, scene construction, spatial analysis, and also the software form itself. And the fourth one is the new function that we have shared in our conference this year in September 2020, which is the distributed GIS technology. So here we have 4 components: the distributed geospatial data engine, GeoBlockchain, and then the distributed geospatial analysis and processing technologies, cloud native and edge GIS technologies. And the last one is the cross-platform. So cross-platform is means that we have we only we able to be open not only in Windows operating system but also in Linux operating system as well. And SuperMap itself has so many kind of terminal products, not only in desktop but also we have our products for cloud-based, which are the iPortal and iServer, and then for the mobile terminal we have iMobile and iTablet. So that's all the products of the SuperMap. Okay, next is about our topic for today presentation. Okay, first. Okay. Okay. For today webinar, we will discuss more about cadastral, especially the 3D one, the 3D cadastral. But some of you may be not familiar with cadastral. So here I put a definition about the cadastral. So cadastral itself is normally a parcel-based and up-to-date land information system containing a record of interests in land. For example, the rights information, restrictions, and responsibilities as well. It usually includes a geometric description of land parcels that link it to other records describing the nature of the interests, the ownership or control of those interests, and often the value of the parcel and its improvements. It may be established for fiscal purposes, for example, for valuation and also the equitable taxation. Legal purposes to assist in the management of land and land use for planning and other administrative purposes, and enables the sustainable development and environmental protection. So yeah, so basically in a nutshell, cadastral is about how you can keep information of your parcel containing not only the geometric itself, but also another important information such as the legal aspect itself. Okay, So that is the first one about the definition of the cadastral. But the background itself, why we discuss this topic for today's session, is because of during the last 2 years, during the last 2 centuries, population density has increased considerably, making land use more intense. So it was shown by the number of population always increasing in every year. This trend has impact on the increasing need of housing itself. Humans also adapt by carrying out building developments both up and down, not only for housing but also for infrastructure as well. So as you can see in the last picture I put here, not only have an effect on the building for housing but also for the infrastructure such as for the subway rail station and another infrastructure as well. And this is a saying that most land administration systems today are not adequate to cope with the increasingly complex range of rights, restrictions, and responsibilities in relation to land. Existing cadastres, which are still based on 2D paradigm, needs to be considered and adjusted to today's world. In order to answer the emerged questions that are how we could cope with the 3D-based information system, 3D-based physical determination, 3D-based geometric description, and etc. So that's why we need to move from the 2D cadastre to the 3D cadastral as well. And yeah, so this will be our main discussion for today's topic. We will not discuss more about the theory, how to cope with 3D cadastre, how is the legal aspect of the 3D cadastre, but more on the how we could, as a GIS software provider, we could give you a 3D digital cadastre model that will support your 3D cadastral concept as well. So yeah, this is our title for today's session about the design and visualize 3D digital cadastral with SuperMap iDesktop. Okay, so the software that we will use for today's session is the first one, only this one, the SuperMap iDesktop, our desktop terminal products. But this one is special because we put our 3D cadastral plugin on it. So actually, this product is you can find it in our official website, but the one with 3D cadastral plugin only available in this session, in today's session. So yeah, for the participant that join for today's session, you could access this QR code. You could download our 3D cadastral plugin by scan this barcode. And then during the processing, we will use two different data. The first one is the drawing file. So actually this is a floor plan drawing for each floor. So since we will create a 3D model, of course we hope you have your drawing file for each floor, not only for the first floor, so that we could be able to achieve the 3D model of it. And the second one is the original info file. So actually this original info file is kind of database that consists at least this information: the parcel number, the building number, floor name, household number, and the last one is the drawing name. But of course, if you have more than these five information, such as the information about the owner, about the legal aspect of your building, and etc., you could put that. But at least you need to have these five information. And please make sure that the file for this database for the original info file is in the format of the CSV, and for each field was delimited by this vertical symbol, or otherwise the software will not be able to understand how to separate between the each field. And this one is about the data. Maybe you are a little bit confused why we need to have the drawing file and also the database information. So actually these two different data about the original info file and the drawing file, it has a relation. So these two data is related to each other. This parcel number, building number, floor name, household, and drawing name was described about the drawing file. So make sure one of the important things you need to sure is that the drawing name in your original info file is need to be the same with your drawing file. So yeah, so then the software will be able to understand about what parcel number is your drawing file, what is the building number of your drawing file, and other information. And the next one is about the processing step. After you have prepared your data, we will do these 4 processing steps. So this is actually the general step. And after this, I will show you about the specific workflow for each processing step. So in the first processing step is about the data management. In the data management, you will do some processing, not processing, just data preparation and also importing the data. You need to make sure if your data is already fulfill the minimum requirements, such as you need to have at least 5 information for your database information, the original info file, and then you need to make sure if your drawing file is in the format of TIFF format. And then yes, that's all for the first data management step. And then the second one is the digitization. So after you import your data, and you have make sure if your data is already fulfill the requirements and do some setting on it, you will go to the next further step to do the digitization. So here you will vectorize the attribute, vectorize each object in your building, including the room, the roof, the door, the wall, and etc. And also you will also be able to put some information on it, the attributes for each object, such as in case you will need to put the information of the legal aspect about the owner and etc. You could do that in this process. And the second one is, and the third one is the 3D modeling. In the 3D modeling, we will do a linkage styling between your 2D data to the 3D data. So in the digitization, you will not only vectorize your flooring drawing file, but also you will put some height information on it, so that in the third process, you will be able to do the linkage 2D and 3D styling. So you will get your 3D model from your 2D data by extrude your 2D model, your 2D data from their height information. And last is the visualization. So after you get your 3D model data, your 3D cadastral model, you could publish your data in the cloud-based system, and then you could put some analysis, spatial analysis on it in the WebGIS platform. Okay, this is for the general information of the processing step. And for the workflow, this is more specific that we will do it for today's session. It consists of about 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. We will do this in the SuperMap iDesktop with Cadastre plugin. Start from the build a new cadastral data source, and eventually we will have the 2D and 3D linkage model. Okay, so maybe after this, I will share my iDesktop and start the tutorial. All right, okay. Okay, but before I move to the SuperMap iDesktop, I want you to understand about the data that we will use for today's session. So I have explained to you about 2 data that we will use for today. It consists of the flooring drawing file and also the parcel information or the database or the original info file. So the left picture is the drawing file that we will use for today. It consists of 3 different drawing for the first floor, second floor, and the third floor. And also you need to have your parcel information that consists at least these 5 information: parcel number, building, floor name, household, room, and also the drawing. And please make sure that your drawing file is in the form of TIFF format, and for your parcel information, is in the form of CSV file, and for each file was delimited by this vertical symbol, this one. And don't forget to make sure that your drawing file is in the TIFF format, or otherwise the software will not be able to detect your drawing file name. Okay, so now we will go to the SuperMap iDesktop. So yeah, I hope you already have I could successfully share my iDesktop screen. Okay. So this is how the illustration of SuperMap iDesktop. We already use this from the first SMC until today SMC, but what makes different is because for this iDesktop, it has the Cadastre Vectorization plugin, this one, that you will not be able to find this plugin in the usual iDesktop that we have shared in our official website. So that for this plugin, you could access it by, I have shared the link to download in the previous presentation. You could scan the barcode and download the software, and it will be automatically 90 days 90 days trial free for accessing this cadastral vectorization plugin. So here in the cadastral vectorization plugin, it consists of many functions. Start with the building data source until there is a manage editor here. And actually, this function was located sequentially. So after you build the data source, the next process is create the original information and then import the drawings, and after that is you need to define the vectorized information management, and until the last one is we could use some export process to build your model from your 3D data, so from your 3D cadastral model. Okay. Okay, first, after you have make sure that you already prepare your drawing file and also your original file, the first process is we will build our data source. Here in the top left corner, you could find the building data source. You could have a click on it. And the first process is you need to define the coordinate system of your data source. And virtualization is my data located in Turkey, so that's why I will define the coordinate system as the WGS UTM zone 36N north. And the next process is define the target workspace. Here I will define my target workspace here with the name process. And after that, we will need to import our original info file, the drawing info file, the one that in the format of CSV. Okay, here, this is my file. Make sure if the format is CSV, and then click OK, and wait until the process completed, until you could find that your project file with name for now is I have defined the name as process was already appear in the workspace manager, and it will automatically have two different data source. The first one is the map manager and the second one is the vector manager, and it will automatically obtain after you build the data source. Okay, actually if you have a check on each data set here, such as the first one I want to check in the point real data set, this one it will have no records data. It will have no records data because we have not started to do any processing in this cadastral model making. And also for the whole data here, all of the data here will be modified along with our processing sequentially, start from the original information managed and until we have the 3D model. So don't worry and don't delete any data here. And next is, I want to show you about the original info. So the one that we have created in the CSV file, maybe I would like to give a look the original file. Wait a minute. So actually the original file will look like this. So as you can see here, I think it's have not shared successfully. Okay, yeah. So as you can see here, this is the original info file that we will use to define the information of the drawing file. It has 6 fields, as you can see here. The first one is parcel, second one is building number, and then floor name, household, room, and also drawing. And this field actually define my drawing file with the name of this file. This is the name of my drawing file. And as you can see here, this drawing file, it has number parcel 5 and the number of building this number. And this, if you have a look here, this drawing file, this drawing file, it consists of many objects: bedroom, bathroom, kitchen, and etc. And it has 3 floors: first floor, second floor, and the third floor. And also it has the household number 12, 13, and 12 and 13 here. And yeah, actually this original info file is describe the information of your drawing file. You could make it by your own by creating it in Excel, Microsoft Excel, and then export it as a CSV file. So here, please make sure that it was delimited by this symbol, this vertical symbol, or otherwise the software will not be able to detect how to detect each field, because the software, the SuperMap iDesktop, will separate each field based on this vertical symbol. Okay, now I will go back to SuperMap iDesktop. Okay, I think I have back to the SuperMap iDesktop. So here, after we create the build, after we build the data source and also import our original info file, you will have the original info file here that consists the same field like your original info. But then we need to define the original information. Here you can have a click in the original information management, and here we will be asked to define which field is for the parcel number, which field is for the building number, and etc. So now you could just select the parcel that related with the one that needed to be defined: buildings, floor name, household, and the drawing name. Okay, now I have fulfill this column, start from the parcel number and also until the drawing name. And then you could have a click on OK as you complete it. And now I will show you how the original, how the result looks like. So after you define each field previously, you will have this original info link dataset. Now let's have a look on this. And here we will only have 5 main fields. It will be different with the one that we have not defined before we do the original information management. Here we have 6 fields, as you can see here. Start from the parcel, building, floor, household, room, and also drawing. And after we do the original information management, and we only will be asked to define 5 fields, right? So it will create a new field, namely original info link, that only has these five main fields: the parcel, build, floor name, unit number, and the map name. Okay, after you do the original information management, now we could import our drawings. Import your drawings. Please make sure that the drawing format is fulfill this image bitmap format. It could be IMG, TIFF, or TIFF with double F, or TIFF with one F. And then you could click open. And here, the software will automatically define the parcel number and the building number of your drawing file. And then you could import and wait until the process successfully completed. And anyway, if you have any question related with my tutorial, you could drop your question in the Q&A chat box, and I will answer that question in the last session. Okay, it seems like I have successfully imported my drawing file, and it will appear under the map manager data source, this one. And the name of the drawing file will be changed. It will be changed by this format. T and then the number of building underscore the number of parcel. Sorry, I think I made it wrong. T and then the number of the building, the number of the parcel underscore the number of the building. It will automatically change based on the number of parcel and the number of building that already defined when we import our drawings previously. Okay, the next process is the vectorized information management. Okay, actually will be very useful if you're willing to define the same floor height and the same floor height and define the first floor elevation. So for some building, they have a similar height for each floor, such as 5 meters, 10 meters, and etc. But in case if your building doesn't have a similar height for each floor, you could modify them after you get this vector. After you modify the data under the vector manager in the next process. So for this time, I just want to define the similar height for each floor by the number of 3 meters. So this is the unit for this height is meter, and then you can click OK. And the next process is, oh, before that, I want to let you know about what is the impact after we do the vectorized information management. So here, if you right click in your vector preset info and browse its attribute table, you will be able to get this attribute table. And here, since we already defined the floor height, it will automatically fill this floor height column, this floor height field, with the number of 3 because we already defined the 3 meter as the floor height for each floor. This is floor 1, 3, and 2. And also since we define the floor altitude is 0, okay. The floor altitude is 0, so it will automatically define the altitude for each floor. But I think here the software is kind of detect a wrong floor because he put the third floor as the second one. So here I will change the floor altitude. This is for the first floor, the altitude is correct, 0. But for the third floor, since this is the roof, this one is for the roof, so it should be have altitude not 3 but 6. But I think we could modify it later. Okay, I just want to give you a suggestion that you need to have a check on your original info and also in your vector preset info to make sure that the software has successfully defined the altitude, defined the height for your data, or otherwise you will not be able to get a proper model, 3D cadastre model eventually. Okay, next is I will show you how our drawing file looks like. Okay, this is how the drawing file looks like. So actually, this drawing file is not only illustrate the first, second, and floor drawing file, but more than that, it actually have for the underground drawing file, the first floor, second floor, the roof, and then from the horizontal section, and etc. But for today's session, we will only use these 3 drawing. These 3 drawing for the first floor, second floor, and the roof. So it should be for the first floor, second floor, and the roof floor. Not floor, just the roof. And then since we only use these 3 data, these 3 part of this picture, not the whole picture, so that we need to do clip process on it. To do the clip process, we have the drawing clip region function here. I think we could just close this map and start drawing the clip region. If you have a click in the drawing clip region, you will be asked to define what parcel number and what building number you're willing to be modified. We're willing to draw the clip region on it. And since we only have one drawing file here, so that it will only give you one option to select. And then you can click OK. And as the process completed, you will get this map, the map clip bounce map. Actually, we do some modification for our map here, the map clip bounce. And this map clip bounce actually have been created by the software from the first time as you successfully building the data source. And here, if we open the drawing clip function, it will open the map clip bounce map. And this map is consists of these three layer. The clip bounce, this is the thematic layer of the clip bounce, and also the drawing file itself. And now we will be asked to draw. We'll be asked to draw each region. It's for the first floor, for the third floor, and for the second floor. If you remember, that the software is detect the third floor as the roof, right? So that when we draw the third floor, it should be the picture for the roof. But for now, I will draw it sequentially. Start from the first floor. It should be here. Just draw an area of drawing file for the first floor, and then when you finish, it will automatically move to the next floor. Here, I will draw for the third floor, which is the roof, and then the second floor here. And if you have completed your area drawing, you can right click in the map and have a uncheck on this display current floor, and you will be able to display the whole floor clip area. This is for the first one. This is for the first floor, second floor, and the third floor are for the roof. And next, actually, the objective for this processing step is that because we're willing to do the clip processing for our drawing file. So next, we will do the batch clip, and we ask to add the base map. The base map is our drawing file itself. Click OK. And for the clip region, we will do some clipping process for our drawing file with these three boundary area of that stored in the clip bounce dataset. And then click OK and wait until the process completed. And then after you do the batch clip process, you will get these three data. It will show you like this. Maybe I will show you how the result looks like. It will show you like this. This is for the 0. 0 is for the first floor. This is 1. 1 for this is for the roof. And 2, this is for the second floor. So yes, after we do the drawing clip region, now we will be able to get the three different picture for each floor that refer to our drawing file here. It will separate your drawing for each floor. Okay, next is as you can see here, actually this data, even the data format is in a TIFF format, but it has no spatial information on it. It has no location information. So that actually it will be very important to us to drawing a location registration. But since for today's session, I have no data that could give me the location information of this drawing file, so that I will just skip this and go to the next step, which is the drawing scale correction. So actually, since in the first process we have defined our drawing file in the projected coordinate system, right? So actually it will put it in area that located in that projected coordinate randomly. That's why we need to define the scale correction here, because the scale of this picture is put randomly. So we need to define the scale correction on it. How to define it is you could use the drawing scale correction, and it will head you to this new map, this map image scale, and it will automatically import your image scale dataset and also your drawing file. The one with the 0 mark, it should be the first floor. The 0 one here, it should be for the first floor. And how to define the scale, how to correct the scale is in the drawing file. It's commonly we could have the information of the scale itself, such as here, as you can see here. Actually, the number of 150 for this line, it means that this line, it has length 1.5 meters. So we just could drawing a line for this part, for this 1.5 meters, and then you find that this line that I have been drawn before, has length 1.5 meters. And I will uncheck in the horizontal correction, because if you give a check on this, the result after you do the scale correction, the result it will rotate your original file. If you give an uncheck on this, it will not rotate your file. And then click OK. I think I could close this, and now have a look on the result. So after you do the scale correction, the file for the first floor, the one with this 0 mark, it will be changed. Not previously it should be 0 underscore by clip, right? But after we define the scale correction, it will be changed into by scale, underscore by scale. So this means that this picture for the first floor has been corrected. And now let's take a look how it looks like by add it to the new map. Since previously when I do the scale correction, I uncheck on the horizontal correction, so that the result will be not rotated. But if you give a check on the horizontal correction, the result will be rotated. Follow your scale line drawing. Follow your image scale drawing. Okay, this one is already corrected. Now let's take a look how it compared with the other picture that have not corrected in advance. So it should be in the previous process, it should be located here, right? But since this data, this 0 picture already defined, already corrected, the scale corrected by this scale correction function, it will be only the one that have a correct scale. So yeah, maybe I will show you again. This is for the 0 picture, and if I do zoom in to it, it's located here, right? So it will give you a different scale with the other. So here for this 0 picture, it already scale corrected, but for the rest we're not. So to do so, to change the scale of these 2 remaining picture, we will do the registration point picking up. So here in this pick up registration point, actually we will not only correct the scale information for this 2 picture, but only we will register for each picture, so that we will be able to get a good location, good position for each picture. So the final result, it should be these 3 pictures will be overlaid each other. Okay, now I will just close it and go to the next process, is pick up the registration point. Actually, this is kind of image to image registration for these 3 picture, for the 0 by scale, 1 by clip, and 2 by clip. And to do this pick up registration points, you will be asked to at least pick 4 points that represent the same location for each picture. such as in here in my picture, location which are same for these three picture is here, and then here, this one, and this one. This is for the first floor. Now we will move to the third floor. It should be located here. I hope you could do this digitization sequentially, same from the first until the last picture, and then this one for the last. And now we move to the second floor. The point it should be located here. This one, and the last one is this one. So now we already picked the registration points for these three pictures, that we know that each point was located in the same position in X and Y coordinates, but of course in the different elevation, because this three picture was located in the different floor, different elevation. And after you pick up the registration points, you could go to the next process, the batch registration. In this batch registration, first you will be asked to add the base map. It should be the one that already clipped or already scaled corrected. This three picture, not the original one, not the first one that we have put in the first process. It should be the one that already clipped and already scale corrected. And we will do this registration based on the point check, and then you could click OK. And wait until the process successfully completed. And after you do this batch registration process, you will get these three different files. It should be the one that already scale corrected and registered in each other. Let's take a look how it looks like by add it in new map. All right, yeah, this is how the result looks like. So I show you, this is for the second floor. I think this one is for the roof. This is for the first floor, second floor, and this one is for the roof. So it already scale corrected and also already registered each other, so that as you can see here, each picture was overlaid each other. It already located in the same X and Y position, but since it may have a different elevation, we will define that in the next process. Okay, after we do the registration, the next is about the house vectorization. You could go to the vectorization tools and you will find the house vectorization. You will be asked to select what parcel number and what building number of your drawing file, and then click OK. And you will find this map, cadastral vector map, and it already have this different object for this layer, including the room, the door, the wall, roof, border, other, and also the balcony. And we will do some digitization for this. So actually how to do that is, first in the cadastral vectorization window in the right side, if you click on room, the pen editing tools of room layer will be activated. If you have a click on door, it will activate the door editing pen tools, and also for the wall, as you can see here, the outer outer contour is for the border, roof, other, and the last one is the balcony. Okay, okay. Now I will show you. To how to digitize. And you're also able to change the floor. So first, I want to do the digitization for the first floor. Here, I choose the first floor, and I will digitize the room. Okay, I will digitize the room. You could just digitize. I think I make it wrong. It should be here, 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 and right click when you finish. This is we already digitized the room, and then I will digitize the door, which is here. And then digitize the outer. I think this is takes time. Actually, I have prepared the data that I already do this digitization process in the previous session, because this may take a long time. So I will show you directly how my result looks like. So this is the result looks like. I think I will delete my wall first because I want to show you how to create the wall. Okay, here I have prepared my data and I have done the digitization for the room. Here I have digitized the room. For the balcony, I also assign it as a room, but I will also draw the boundary of the balcony here. This is the boundary for the balcony. This one. And this one. It may doesn't look so clear. This one. And after that, beside that, I also have digitized for the door. So look at it here, the one with orange color.
Hello.
This one. This one. So this one.
And this?
And digitize the door. And then the border. So actually the border is the boundary of your home, boundary of your building, and I'm not include I have not include the balcony as the border, only the border of my main building. This one, this is the border. Why I created this border is it will help me to obtain the wall, I will show you later. And also I have draw the other area, this one. This one.
Hello.
So
Hello,
if
Candice.
I turn off
another
layer, if I turn off the drawing layer, it will show you like this. This is for the room. The other room, this is boundary, and then this one is the other. Others means that it's not categorized as the room, as the door, as wall either. So it kind of just free space room. I categorize it as a border. Sorry, as the other. So next is about create the wall. So it will take a long time to create the wall. So we have here the wall clip function. Actually, the main process for this wall clip function is that for Okay, I think I have not shared my another screen. I'm sorry. So I will repeat my explanation. Oh yeah. Okay, thank you, Jason, for reminding me. Okay, I will repeat the explanation here. For the prepared data. So previously, the last in the in the different iDesktop, I have shown you how to digitize the room, right? How to digitize the room, but actually I have prepared the data. Looks like I need to re-explain it from the start. I have prepared the data. I have done the digitization for the room, for the other room, for the balcony, for the outer of my building, for the door, and also for the outer of my balcony. And maybe if you want to have a look here, is that this is that I have not created my wall yet, because to create the wall, we have the wall clip function. We have the wall clip function here. To this wall clip function will help us to do the clipping between the boundary of our building with the building inside of it, so that it will give you the remain area that will be categorized as the wall. So now let's take a look how it looks like. Here I will clip my room data set, my door data set, and my other data set. Other data set means that this one, it means that this one, the one that not categorized either as the room, either as the door, either as the wall, and etc. Because this is kind of just a free space, so that's why I categorize this as the other. Okay. And the border is the boundary of my building. The boundary of my building, only the main building. It not be included. The balcony will not be included in under this border. And now I will let you know how the wall clip function will be useful for us to create the wall. So here we will do the clipping for the room data set, door, and other, and clip those data with the border data set. And now how it will look like, we will get our wall. This is the result. So this is the result after we do clipping between our border data set with our room, door, and other data set. So we do clipping for this data and it will show you this result. And it will give you this result. Okay. Next, we could just copy this result for another floor. For some case is that the building it has similar location for each room for each floor, so that you could just copy this digitization, this vectorization result for each floor. But if your building it has a different room location for each floor, of course you need to do further digitization for different floor. But because of the limited time, I just want to do the copy floor. So we have the copy floor function here, and I will copy my room, door, wall. I think no need to copy the border, and also I will copy the other data set, this 4 data set. I will copy that from the start floor until from the first until to the first, and it means that I will do this copy for one time only, and click OK. Now let's take a look how it looks like. So yes, here I copy my my room for the first, and actually this, even though this floor name is 3, but actually this is for the second floor. This one. Floor altitude, it should be, oh yeah, for the floor altitude, here it should be 3 meters, because we already defined the floor altitude is 3, right? So for the bottom one, the floor altitude is 0, but since the height is 3 meters, so it should be the floor altitude is 3. And now let's have a check for the wall. Floor height is 3, floor altitude is 3. I think that's correct. And then let's take a look for the door. It has copied the door for the 0 floor and the first floor. And in the floor altitude, it should be 3 for the second floor. And then for the border, we no need to do some modification for the border. And then for the roof, the floor altitude, it should be 6. That's correct. And for the other data set, the altitude is 3. Yes, that's correct. For the floor height, I think I could define it as 0.3. Altitude is the elevation. Floor height is just the height for the object. Okay, now I will close this attribute table and go back to my model and to my cadastral vector map. So previously we have defined the height, and also we have vectorized the cadastral information. And actually, if you're willing to put some information for each room, for example for this room, you could just open its attribute table, or maybe I will show you later about this to add some information for each room. Okay, next is after we digitize for each room, after we already make sure that the height information for each room is correct, and also the elevation for each floor is correct, you could go to the next process, which is the 2D and 3D linkage editing. So in the 2D and 3D linkage editing, we will actually, the main objective here is to stretch your 2D data in order to obtain the 3D model. And here we need to put what height information that we could refer to in this stretch field. I think I will go back to open one of the attribute table of the data set under the vector manager here, such as this room. So here we will do stretching based on the floor height, because the height information will define the height of the object, while the altitude will define the elevation of the object. So it will be different. For the first floor, the elevation, it should be 0. For the second floor, since we define the height of the building is 3 meters for each floor. For the second floor, the altitude, the elevation, it should be 3. And then for the third floor, if any, it should be 6. For the fourth floor, if any, it should be 9, and etc. So that's why this is the difference between the floor height and the floor altitude. And for the roof, I forget to define the floor height, it should be 0. Oh, that's right. Okay, so that is the difference. Height is height of the object. Altitude is the elevation of the object. Since we define the 3 meter as the altitude as the height of each floor, so it should be the multiplication of the 3 number for the floor altitude. Okay. Now let's take a look how the 3D model looks like after we do the 2D and 3D linkage editing. Here, please make sure that you already define the correct field for the stretch field. It should be floor height. Floor height. Okay, and click OK. And this is how the result looks like. I think I have not copied the balcony. Okay, I will repeat the process. The balcony, I will copy that from the first until first. And let's take a look. Yes. Yeah, it's already correct here. The altitude should be 3. Okay. Now let's take a look how the result looks like by 2D and 3D linkage. Don't forget to change the stretch field, the correct stretch field. I put it in the floor height. And click OK when you have make sure you already define it correctly. And yeah, now we will get this result. So maybe because of the limitation of the teleconference, you will not be able to show it smoothly, but actually in my own computer, I can get this movement of this 3D model smoothly. Maybe I will show you one by one layer per layer. This is how the room looks like. And then the door. The roof, the balcony, only the fence of the balcony actually, and the wall. Here I define the same position of room for each floor, just an assumption. But in case if you feels like you need to redraw it because of your position of the room for each what is that, for each building, for each floor is different. You need to draw it manually for each floor. But this today's session is just for example. I will show you how to copy the floor. Okay. Got it. Okay, this is the result. And another need to know is that one of the more important information of this 3D cadastral making is about put the legal aspect information for each building. So there is case that there is a different authorization for each floor, different owner for each floor. So you could put it here. So maybe for example, I'm going to give further information for each room. I'm going to put I'm going to put owner information for this room and all of the room. So we able to do that by add new field for this room. You could right click in the room properties And in the attribute table, you could add new column, new field, namely, for example, owner, and the type, it should be text. It should be text, and click apply. So now we have new field, namely owner, and here we are willing to put the owner information for this room, for example. For example, we're willing to put the owner is Mr. A, and then for this one, the owner is Mr. B. This one, the owner is Mr. C, or maybe you're willing to add another information, not only the owner, maybe for example the last update information and etc. You could do that here. For example, this one is November, and etc. You could do that by add further attribute information for each object within your building. Okay. I think I will show you more detail about this 3D cadastral model. This is for the room. This is for the door, for the wall, for the roof, and also for the balcony. For the balcony. So now another question is emerged. How to export this 3D model? So we provide our function here. If you could find that under the cadastral vectorization and under the manage edit, here we could build our 3D model. I would like to do the export for this model one by one per object. Per object, start from, I will do export for the room only, and make sure you select the correct stretch field. Model room. And then the second one, I will build the model for another layer for the wall. So I will delete the rest, only export the wall, because I'm willing to do the different styling for each object, for each model building. So if you do convert all of them in one model only, it will be hard for you to change the layer style. I will show you later. This should be the floor height model for the wall. So it will automatically stored under the vector manager data source. Okay, the next one is for the door. The stretch field, it should be the floor height model for the door. Click OK. And then for the balcony, room, wall, door, other first. Other, the stretch field is floor height, because we put the height information in the floor height, right? And then the result data in the vector manager with the name of model for other. And then the next one is for the balcony. I will delete the rest, only remain the balcony, and the stretch field is floor height. The result data will be stored under the vector manager data source, and the name is the model balcony. Model balcony. And the last one is export, build the model for the roof. For the roof, it's quite different because we will use the build pitch roof here. build pitch roof. It will allow you to define the slope in the parameter setting to define the slope of your roof, so that you will be able to get a roof with this slope roof, and also with this floor altitude information. So yeah, I will just let it default. Maybe give an underscore here for the roof name, and I will not change the slope number for my roof, and just click OK. And now let's take a look how the model result looks like. If I open it in plane scene, I think, and you're also able to open it in the spherical scene. Just want to show you in the plane scene. Actually, it's not clear enough, right? Because the model will automatically in the white color. But now I will show you how to give different color for each object. Okay, first I will change the color for the roof. You could click on your model roof here and go to the style setting. Here we will be able to change the color. Okay, this time I will change it into gray, I think. And also you will be able to change the transparency. Let's suggest this one. And then I will change the color for the room, such as red. This is how the result looks like for the room. And then the color for the door, maybe yellow. And then the color for the balcony, maybe blue. And the last one is for the wall. I will give you green. Okay, I think this is the final result of our building. So of course you could make it more beautiful in case you are willing to have some different requirement about the color for each object. You could do that by change the color of your each layer in the style setting. In the style setting here, you can change the foreground, the background, the transparency, the flow mode, and etc. And also you will be able to put some texture setting on it in case you have your own texture for the building. You could put it here. You could select the file. As long as if your file is in the format of these screen pictures, you could use that for the texture setting. And after it finished, you could just save the scene. And now, every time you're willing to open your scene, you just could open your scene in the iDesktop, and it will give you the visualization of your scene. Actually, we could also define the location information of this model. So because in the previous step we have done is that we have not defined any coordinate information of it, only the coordinate system, but not the exact location. But if you have your reference data that could be used as the reference, either reference points, reference area of this for the location information of your building, you could use this object position registration. So it will ask you to do the registration between your data and also your reference data. It's kind of doing the registration, georeferencing, and the result is you will obtain your model that already corrected correctly located in the exact location. Okay, so I think that's all for today's session about this 3D model making by using the cadastral vectorization in the SuperMap iDesktop. Now I will go back to my presentation. Let's wait. Okay. So beside the 3D model making by using the 3D cadastral vectorization plugin in SuperMap, after you get the 3D model from our software for the desktop software, you're also able to do the further application and development on it, such as this one. So the results could be published in the web page. So the 3D model that we have been created in the SuperMap iDesktop, and you could create a 3D image of it, and then you could publish it as a QI application to a web-based application, such as this one. And it will be very helpful for you to share it with another user, so that it will have your supervisor, your client, etc. and you will access the 3D model to that role that we have been created before in the SuperMap iDesktop. We will share it into a web application. And another thing is that you will not only be able to import it, to publish it as a GIS service in the web base, but of course you could add some special analysis function on it in your website application by adopting from the SuperMap iDesktop. This one is we have the feature analysis, skyline, and etc. And also we have our capability to do the legibility checks. So this is not provided in our desktop terminal product. You need to do this further development on it in order to obtain this legibility check analysis. Here, you could do some analysis vertically and also horizontally to know which area was violated the rule. And this is, of course, will be very useful to implement the building boundary both horizontally and vertically legal aspects. And also, yes, about the 3D analysis. So SuperMap, one of the SuperMap very impressive capabilities about the handle the 3D data. After you consume the data, after our software consuming the data, we also provide many kind of the 3D spatial analysis that could be implemented in your 3D data, as well as display in this slide. Besides its functionalities in desktop terminal, you also allow to bring the spatial analysis into a cloud-based system, cloud-based application. So such as the skyline analysis, profile creation, viewshed analysis, and etc. It could be applied in such a web-based application for your 3D cadastral model, of course. Okay, I think that's all for today's session. So thank you so much for your attendance. Thank you for your attention to hear my presentation about this 3D cadastral model. So actually, the data that we will use for today's session is confidential, so I apologize that I couldn't share it with you, but I will share the 3D cadastral plugin software. You could access them. You could access it by do scan for this barcode. I will show you later. And in case you have another question that you got it after you try the software, you try the plugin, you could let me know by reach me in the email of candice@supermap.com.